I'm going to open up this document, session 1, software, part 1. Okay, and I'm going to show you the device that I used instead of a computer when I took statistics in 1967, I think, or something like that, at Brooklyn Poly. It was an introductory course for, I think, you're fresh, for freshmen. When I went to, I think it was 67 when I went to Brooklyn Poly as a freshman. That's what I was using. It's an electromechanical calculator. That one that you see up there adds and subtracts. That's about all it does. It takes, we'll make a sum of a number of numbers or something like that. We had more sophisticated ones, which did exotic things like multiplying and divide. There are versions of them that also, took square roots calculated squares, took square roots, and so on and so forth. But that's literally what we used. So since then, the world has changed, right? There's been enormous changes in the world. Back in those days, the way we used to handle data and calculations is, for the most part, most people use something called a spreadsheet, basically a ledger. Or I don't know if you've seen the old, if you saw old movies such as a Christmas Carol, where they're working with these old books and ledgers, and they're actually writing down line by line credits and debits and adding them up at the end of the page, and they're working with columns and rows of numbers. And as they get to the bottom of the page, they'll add up all the numbers that were on that page, and they'll carry the total over to the next page and continue to add numbers to it, subtract numbers from it, and so on and so forth, and make other calculations, multiply, divide, or whatever, and take the results, put that on the top of the next page, and carry it over. Problem is, if you made a mistake on page 1, and you're down to page 10, you had a lot of issues to deal with between there. You had to recalculate everything all over again. Well, that was pretty. That was pretty much a disaster. It was really very difficult to do complicated calculations using a system like that. Well, around mid 70s, a couple of guys put together a program. Dan Bricklin and a partner of his put together a program called VisiCalc. VisiCalc was the first spreadsheet on microcomputers. I'm going to play a quick video on this. This software. Of course, one thing we mentioned is the idea of using these spreadsheets, these visible calculators, or these computing programs. Now, these programs have various functions in them, including statistical functions. Some of the other programs that you might run into are things called database programs. Anybody ever work with a database program? Okay, what kind of program have you worked with?
Something actually older. It's called FPIMS.
Okay, good. And there's something that was popular called DBase a while ago, and I think you had your hand up.
I can't remember anymore, but it was for Project.
Yeah, Fox Pro maybe. FileMaker Pro is still active and still very popular now. In fact, FileMaker Pro is a program that's cross platform, runs on Windows and Macs, and you can download a 30-day demo of it for free. It's an expensive program, but you can play around with it if you're interested in it. But database programs are programs that their main use is to manipulate and to store and manipulate data, to make it so that the data is accessible. And it does that by storing the data in files, and it's a simple phone book, basically, is a database. Modern databases are much more capable than just the old kind of store a material in a line of data, or in a simple linear database. So something like this, something like last name, first name, city, address, and so on and so forth. Now there's relational databases. There's all sorts of special databases that take a standard format called SQL, and so on and so forth. Commercially, there are database programs that cost millions that handle enormous volumes of data very quickly. You can imagine if you're running a phone company or something like that, you have to store enormous amounts of information. Okay, for instance, a company called Oracle, which is one of the biggest companies in the world right now, is basically a database company. Beyond that, there's also software that we call vertical software that's made for a specific purpose. For instance, there are programs that are made for nothing but doing statistical calculations. The one we're going to be using here is called SPSS. Some of you may have heard of another program called SAS. The Department of Health tends to use that for a number of purposes. There's a program called R, which is a free program that you can download, open source it's called, program that you can download from the internet. It's a little less friendly than some of the software that we're going to be using, SPSS particularly, which is menu driven. But some of you that might be a little bit more confident with using computers might want to consider downloading and playing around with it a little bit. So we're going to be playing with a bit of this stuff right now. So I'm going to open up the first file that I have on here. I have them numbered on Blackboard. I'm going to open up number 1. Okay, if you guys want to follow it with me, number 1 is an Excel file. Just to give you a beat, for those of you that don't have too much experience with Excel, there are 3 kinds, basically a spreadsheet. I'm going to blow this up a little bit so we can see it a little bit better. Okay, that should help out, I think, a little bit. Okay, basically a spreadsheet consists of any number of rows and columns with cells or boxes. And each one of those boxes is identified, its location is identified by the letter and the number that it's located in. Like that's B6 and this is C7 and so on and so forth. You can have 3 different kinds of things in any one of these cells. You can have a label. A label is just basically text. So maybe this label would be January. And this label would be February. Okay. You can have a number, right? That number can be an integer. That number can be a decimal number. Okay. And you can have a function. A function is you can assign an equation or a calculation to that box instead. So for instance, a function might be if I want to take these 2 numbers and add them together. And the way that I do that is I type an equal sign into that box. The moment I typed an equal sign into that box, you may have seen some changes in there. For instance, right up here in this little editing row over here, this little editing box over here, when I typed an equal sign in there, right, you saw that change. You saw that equal sign appear there, and you saw that this ribbon up here changed a bit. So I'm going to say that I want to add up these 2 numbers, 123 plus 12.345. Notice I typed in 123. I put a minus in there by mistake. I'm going to put a plus in instead. I want to add those 2 numbers up. I just type that in there, equals, okay, and I get a total. Okay. Another way I can do that is I can tell it, let's not add up 2 discrete numbers. Let's add up the location, the number that's in a certain location, equals, okay, this cell, which is, that cell is D4, plus the cell that's in D5, the value that's in the cell D5. Whoops. What did I do wrong there? Did I do that twice? Oh, I'm in D4. I was C, right. Okay. Yeah, circular reference. That's why it gave me that error. Equals C4 plus C3. Okay, and there we got the same total. Another thing I can do to save myself some trouble, so notice anytime you type something in, you're introducing a little potential for error there. Instead of typing in it, I can say equal, okay, and I can point at that cell and click, and it'll fill it in for me. Okay, plus this cell, and hit enter. Whoops. Plus, I hit an equal sign again. Okay, there we go. I can do it that way. I can actually take advantage of functions that are built into Excel. And these functions can be statistical function, engineering functions. There's hundreds of these functions. I happen to know that one of those functions is called sum. And if I want to know something about sum, I can click. You might have seen how I got that. There's a little f of x that stands for function, scientifically usually. So I can click on that and I can get a list of these functions. I can search for one and so on and so forth. I can sort through just the arithmetic ones, just the statistical ones, just the real estate calculations, just so on and so forth. So one of those is equal to sum, and I can use that function sum. I can do that here by just hitting the equal sign and typing in SUM and parentheses, and it gives me a hint. Well, okay, give me the numbers that you want a sum of. Well, I can tell it now. I want a sum of all the numbers that are in these boxes here. C3 through C9. Through is indicated by a colon. Okay, so I'm going to close parentheses. There isn't anything in those other boxes. So had there been, it would have filled this in for me. It would have added those numbers as well, but we know it's going to come out to be 135 again as well. So there's a number of ways that I can use these functions, these cells, and you can build one function on another function on another function, and you can create some very powerful calculation tools within this. We're going to use the statistical ones mostly. Okay, now another thing that's very, very valuable is that if you make a mistake, and this wasn't 123, but it was 223. Well, you've corrected all of these all at once, right? You didn't have to go back and like do these calculations, do a whole string of calculations again. That was one of the things we were talking about when we were talking about those spreadsheets. Okay, so here's another example. Another thing I can do is that, for instance, say I have two columns where one column represents the number of a particular product that I want, number of units that I want to buy, and the second column represents the cost of each unit. So I'm going to click in here, I'm going to put that equal sign in here, and I know I can say, well, I want to multiply those two together to get the subtotal for that particular item. So it's going to be 10 times $11.20. That's going to be $112. Well, now I can repeat that for the next row and the next row and the next row. Well, in Excel, what I can also do is click on one of these boxes, drag down. There's a few ways to do this. And this is one of the places where Excel and SPS, where Mac, the Mac versions or the older versions of Excel and the newer versions of Excel and the Mac version, the PC version diverge a little bit. In the Mac version, if you go over here, there's a little button that says fill. I'm going to click on that and I'm going to say fill down. And it fills down not the same number. See, if I had a number like 100, right? Just a number in that cell, and I said fill down with that number, it just copies that number into all the other cells. If I apply it to a formula, what it does is it says, oh, I understand you meant F3 times G3 is what you referenced as the first cell you clicked into, but then you said fill down that formula. So since it's based on two columns next to each other, I'm going to assume that you mean that the next column should be F4 times G4 and F5 times G5 and so on and so forth. So it actually modified the formula so that it accomplished what you would most likely want to do. Okay, and of course, when I get to the bottom, if I want the total for everything, I could just use equals sum parentheses and tell it I want the sum from H3 through H7.
I'm actually only getting 112 all the way down.
Did you put in a formula there, or did you just do it manually?
Yeah, what's the formula?
The formula was equals F3 times G3,
Thank you.
right? Okay, when you put a formula in there, it changes its mind and it sees, oh, well, these are adjacent columns you're working with, so you must want to repeat this calculation. But if you just put a number in there, it's going to copy that number down. Okay, and if I want the total, I'm going to put an equal sign in there, sum, parentheses, and the sum of all these numbers. And that's equal to $14.99 or whatever. Yes?
So if you're just doing a sum of two numbers, you don't even need to write sum. But if you're doing a sum of a range, you have to write sum.
Well, you don't have to. I could have said, in here I could have said equals H3 plus H4 plus H5 plus H6 plus H7, but that'd be pretty tedious, right? Exactly. And remember, we're just looking at a couple of these functions. I mean, look at all these functions that we have in here: date, hour, time values. We have financial functions. We have let's see, tangent, cotangent. We have geometric functions. We have engineering functions. There's all sorts of specialized functions in Excel. Not only that, but you have packages where you can add on additional functions as well. Years ago, we used to concentrate on teaching SPSS, and we used to get a lot of feedback from instructors in later courses, especially some of the tracks that required a little bit more math, that the students came in there not knowing much about how to use Excel or how to use a spreadsheet. And they were handicapped a bit when they went into these other classes and they had to do a lot of calculation work. If any of you are EOHS majors, you're going to want to be able to use this and so on. Okay, and many, and just in life in general. I mean, it's a great tool for a lot of different applications. Okay, so I'm going to open up the next one I got.
Tony, can I say quickly?
Yes, sure.
Before using the sum function too, I mean, you can, that little box in the corner, the right corner, that you can also pull it down because it automatically recognizes.
Yes, if you look on your version of it, that little box for fill is over in the right-hand side rather than the left-hand side. Okay, I don't know if I can. It's going to be a little bit hard for me to show it on here, but you guys see it there? Where on your PC versions, do you see where that fill button, fill down, fill left, fill right? Right? Does that make sense to you? Right, it's on the right-hand side. How you guys doing at home? FileMaker is horrible. I use it at school. Okay. Nobody asked you. Okay, good. All right. So I put together a quick version of a spreadsheet that might be something you might want to try to apply. For instance, here's somebody's budget. Now this is the debits, the expenses the person has. Let's add them up. Equals sum, parentheses. I'm going to add all these up. Okay, and comes out to $1,740. I'm going to look at how much money that they bring in from salary, tutoring, and from mom and pop. Oops. Sum and the total there. Obviously, we got a problem because where our balance is equal to $1,400, the amount of money that we're making minus the amount of money that we're spending, and we can see that's not very sustainable, right? So now I've said to myself, well, one of the what if kind of features of Excel is that we can go in here, we can modify this. Well, what if I get a roommate, split the rent, $250? Well, I'm in better shape, but I'm still losing money, so I'm going to have to cut back on it. Notice this person really spends a lot of their cash on entertainment, so maybe I'll really cut back, and now I'm in the positive, and I can start saving a few bucks or something like that. But the idea here is that this is a tool to help you understand, organize numbers, understand numbers, manipulate numbers, and to perform advanced calculations on information. Okay, so let's try the next. Maybe by the next one here, we'll start to get into stuff that we can use to apply it to statistics. And this is kind of a start on that. One of the other features that's very valuable in Excel and in many spreadsheet programs is that you can use it to create graphs. Okay, so right here, this is some data on indoor air quality. It's mold spore counts. Took 2 readings outdoors. One was 168, one was 127. We took 4 readings indoors on an area that was suspect and a couple of readings in an area that we thought we didn't have any issues, and so on and so forth. It's kind of hard to interpret these numbers. Would be better if we could see it graphically. So SPSS has built into it graphical functions. So I can highlight these 2 columns just like that, including the headings. And I can go up here, it's warm in here, right? I can go up here and I can change this ribbon to the charts ribbon. Okay, and I'm going to create a bar chart. A bar chart, we call a vertical version of a bar chart, we call a column chart, or Excel calls it a column chart. I'm just going to pick the simplest version of it. And there it does. Bingo, that's all I needed to create this bar chart. I don't need this legend, so I'm going to take it away. Makes it a little bit more obvious. Right? So now graphically we can see, well, the numbers in the 2 locations indoors look pretty similar and the numbers outdoors look much higher. So don't look like this kind of place has a mold problem. And this is something you can use to illustrate, organize and illustrate what the numbers mean in terms of comparisons of one group to another group. And what are we doing a lot of times in statistics? We're comparing one group to another group, right? Okay, so I'm going to go to the next one where we're going to actually start to apply this to statistical functions. I'm going to open this up, and I got a simple list of numbers here. Now, these numbers are between 80 and 95. I'm thinking they're blood pressure readings. Okay, let's say they're 10 people, and a random sample of people from some group, and we want to have an idea of, gee, I see these numbers, but I want to organize it so I understand the numbers a little bit better. A lot of times, the things that we're concerned about with numbers in a population is, gee, what's the average blood pressure for this population, right? That would make sense to know, right? What's the middle value or the average? And the other thing that would make sense to know is how variable is it? Who's lowest? Who's highest? Are most of them in the middle? Are most of them spread out, and so on and so forth? So we're going to do that. We're going to start to apply some of the simplest descriptive statistics that we're going to be working with. Okay, and SPS Excel has functions built into it to do exactly this kind of work. Okay, so first thing I'm going to do is find the mean. Mean is the same thing as the average, arithmetic average, right? So in fact, Excel doesn't have a function called mean, it just calls it average. It doesn't bother with mean. So I'm going to type in AV, and you can look this up with that function, little function table, or you can just start to type in average, and then when you hit parentheses, you know it's ready. It gives you a little warning there that you can see behind me, and it tells you, I'm ready for you to actually give me the numbers now after you put in that parentheses. So if it doesn't have a function, put in that parentheses, well, nothing will come up, or if you misspell it. So we're going to take the average of A1 through A10. Okay, and the average comes out to be 82.5. Okay, now I'm going to take the median. What's the difference between the median and the average? Median is the middle value, right? It's not necessarily the same as the arithmetic average. It's in what we call a normal distribution, which we'll be talking about later on. It is pretty much the same as the mean, hopefully, right? If it's really a normal distribution, but it's not always perfectly. It doesn't always align perfectly with the means. But let's calculate it. So what do you think we're going to use as a function? Let's see if we got median equals median. Sure enough, there it is. There's a function called median. So I'm going to find the median of all these numbers. Middle value. Okay, it's 80, right? Okay, which makes sense. If I were to take these numbers, watch what I can do with these numbers also. I'm going to put them over here. I'm just going to click in there and say paste. Okay, I'm going to paste them in there, and I'm going to highlight these numbers, and I'm going to tell Excel to sort it for me. There's a function up there called sort, and I'm going to tell it to sort column E, and it sorted it for me. Now notice the low numbers on top, the high numbers on the bottom. Well, there's 10 numbers, so the middle, there really is no middle, right? Because there's 5 and the fifth one and the sixth one. There is no, when you have an odd number of numbers, like if there were 100 here, right, 11 numbers, well then the sixth number would be the middle. But we only had 10 numbers, so there really is no middle. So the median is the average of the two middle numbers, 80 and 80 in that case. So the median is 80, right? So if that had been 80 and 82, the median would have been 81, the average between those two. Okay, so the median's 80. So now sorting this also makes it easy for us to do the next thing. What's the mode? The most frequent value is the mode. What's the most frequent value if you look at it now sorted?
80.
Let's see if it works. Equals, see if there's a function. MODE, parentheses, sure enough. And I'm going to take the mode of all these numbers, and it's 80, which is what we expected. Now, one of the things we were talking about is the range, the minimum and the maximum value. The maximum value minus the minimum value is the range. So what's the minimum value? The minimum value is equal to minimum, min. How about min? Parentheses. Sure enough, there's a value called min. I didn't even have to type it all out. I'm gonna highlight those. And the minimum value is 70, as we would expect. The maximum value, max, parentheses. Now, I happen to know a lot of these functions, obviously, so you have to do a little bit more searching than I have to do, or experimenting than I have to do. But, you can see where I'm going with this. These are all built in here. And the range is going to be the difference. The maximum minus the minimum. The range is 25. Okay, it gives us an idea how spread out these numbers are. Okay, so there. We've just done some basic descriptive statistics. We've described this sample of people. Now, this sample is only 10 people, right? Not very impressive, right? Well, how about if we were dealing with 10,000 people? We could do this with a tool like this just as quickly with 10,000 people as we did it with 10 people. And with SPSS, we can do it even more. We can do it even more easily with very large populations. So I'm going to go to the next one. Next file we have here, which is number 5. Well, number 5. We're not going to bother with number 5 for now. One of the exercises that we do is called age adjustment. I think what I'll do is that I'll put together a video on that so that you guys can watch it, but you're not really going to be required to learn this for the test. But I think it's important for you guys to understand what this idea of age adjustment is when you look at statistics, because you're going to be seeing a lot of databases where the data, you can choose the data to be age adjusted or not age adjusted, and so on and so forth. So we're gonna play around with that in the future. So now I'm going to open up SPSS, this program that we're going to buy, and sadly you will have to buy, lease it, because you're going to need it for this course. And I know it's an extra $40 or something. The cheapest version of it is roughly $40. There's a link for you to go. I think it's onthehub.com or something like that /SPSS, where you can go and download the program for your machine. Make sure you buy the right version for your computer, meaning operating system, okay, Windows or Mac. Yeah, it's roughly about $40 plus a couple of bucks of convenience fee, because for the convenience of you paying them your money with your credit card or something like that. But at any rate, you download it, you get a license for it. The license will work for 6 months after you install it on your computer. If you think, I'm going to be taking EPI next semester, maybe I'm going to need this, you can buy it for a year. It's like 70, we won't save that much. Maybe it'll be $70 instead of having to re-rent it for 80 or something like that. But you might want to consider it if you want to have it around a little bit longer. This is a program that normally would cost $1,000 or more, for the versions that you might buy professionally. You can buy the cheapest version, the base version of the Grad Pack, I think it's called. You'll know it because it's only $40, right? That's how you'll know it. Or for the year-long license, it's about $80. It's called SPSS. There's a link on Blackboard. Anybody have any issue getting on Blackboard? Can you get to the course on Blackboard? You're a new student? Okay, well, give me your email address. And that way, or email me and let me know if there's anything that you need that we talked about. And I'll also email you back the some of the materials that we're working with tonight. Okay, so, and I'll make sure you get the links for the online. Yes?
But the $40 one, that one's perfectly fine for this class.
Yeah, the lowest dollar version of it is perfectly okay for this class. You don't need to go for the one that includes regression and special regression package or any of that kind of stuff, or even the full grad package, the base version of the Grad Pack, I think it's called. But you'll know it by the cost. Okay, so, and it's SPSS, not one of these other weird database programs that they sell on there. Okay, so if you have any doubt about it, you can always email me or something like that. Okay, so SPSS, when you open SPSS, this is kind of what it looks like. What does that remind you of?
It's like Excel.
It looks like Excel. It's nothing like Excel. It only looks like Excel. These cells, you can't put formulas into these cells. You can only put data into these cells. You do the calculations using these various menus and so on and so forth. In fact, there's a couple of views here. One of the things that's nice about this, though, is that you can import programs, data from other programs. For instance, I'm going to go in here and I'm going to say open data, and I'm going to navigate to my desktop where I have all this stuff stored. I'm going to go in here to my to my data. Oh, there's nothing there. I know I have files in this folder. What's the problem? Well, the problem is I don't have it in the format that it recognizes. I have as Excel files. So it's looking for SPSS files, SAV. So I'm going to click down here and tell it, well, I want to look for Excel files too. Or you can even go down here, DBase files, Silk Lotus files. And some of you guys may remember those names. All files, show me all files. I happen to know what I'm looking for is an Excel file. So I'm going to click, now it shows me the Excel files. So I can open them. So I'm looking for this one, number 7, because I know that's that happens to be our blood pressure readings. Okay, and what it is that the first column, in the first column, I have 10 numbers, but at the top, the first cell, I have BP for blood pressure. It's the only difference between the file that you saw that we just worked on and this SPSS intro file. But it's an Excel file, so I'm going to say open that file. Then it comes up and it asks me, hey, I found the file. There seems to be basic statistics between A1 and A11, just what I expect. BP plus 10 numbers, right, in that A1 through A11. There's a little checkbox here, read variable name from the first row of data. Well, I need that to be checked because that first row of data is not really data, it's BP, the name of the variable, right? Blood pressure. If I uncheck that, it's going to try and read that BP as data. If BP is not in there and it's just numbers and I check that off, it'll make that first number the name of the variable, which is not very good, and we'll lose that number in our calculation. So it helps to make sure you got that checked off if you need it. So I can click OK, and sure enough, it imports it. Here it is. See, it called it BP, and you can see all the 10 numbers, same 10 numbers that we were working with before. So now I want to do various calculations on this, okay? And I'm going to go over here to analyze. Strangely enough, they would call doing an analysis analyze. And I'm going to go down to descriptive statistics because that's the kind of statistics we were just doing, the descriptive statistics. Descriptive statistics, I'm going to go down here I'm going to use this frequencies that does counts. There's descriptives that does some really basic. As a matter of fact, I'll go there. I'll go to descriptives. And it tells me, I have 2 boxes. You know, a lot of times I'll have many columns here. If I do a survey with 20 questions, you'll have 20 columns of data. If you're collecting a lot of medical information, then maybe 20 or 30 or 50 columns of data, and so on. All different variables, blood pressure, age, height, weight, BMI, and so on. It might be a different column, right? In this case, there's only one variable, so there's only one thing listed here. But if there were many of them, this gives you an opportunity to say, hey, I want to do this analysis on this one and this one and this one, but not all the others. So I'm going to move blood pressure into the right to tell it I want to do an analysis on blood pressure. I'm going to click OK. And SPSS then opens this up and does descriptive statistics. Okay, and what it does is it says the blood pressure, well, there were 10, sample size is 10. The minimum is 70, maximum is 95, the mean is 82.5, and something called the standard deviation, which we're going to do next week, is 7.5. Well, gee, that's pretty interesting. That gives me some more information about this. In fact, you can go in, you can even do this a little bit more in detail. You can go into descriptive statistics and something called explore and move BP into here, and you'll actually get a bit more in the way of statistics, and you'll even get plots. Okay, and these plots can include various kinds of graphical displays of this information. I'm going to click OK. Okay, and let's see what I got this time. Well, now I got all sorts of other statistics here. I got the median, I got the range, I got something called the interquartile range, and so on and so forth. And it also displays the distribution of this data. Okay, let's take a look at this data. Well, one person was between 70 and 75. One person was between 75 and 80. There were 4 people that had blood pressures of 80. One person blood pressure. Now, graphically, I can get a better idea of what this distribution looks like. So displaying data, you get this descriptive statistics gives us a lot of very valuable information, but displaying the data graphically really, really increases our understanding of the data. And this is one of the things that SPSS is really good at and is really going to help us with. Okay, so we want to work with Excel, we want to work with SPSS, and I'm going to just quickly show you there's other kinds of information you're going to work with next week. This is called a box plot. This shows you the minimum and the maximum value and the middle 50% of the values and so on and so forth. Another way of looking at it. This is a stem and leaf plot. There's all sorts of ways that we can display this information. Okay, so we're getting pretty close. Let's see, how are we doing here on time? Yes. Okay. Yeah. Let's stop for a moment and back up and see if we got any questions. Yes.
Tony said descriptive statistics was a choice over there too.
Yeah. I'll do that again. I'll do that again right now. In fact, before I do that, I want to point out to you. You notice that all of these results are in a different window than the data, right? SPSS opens up 2 different windows when you do these analysis. You have a data window and you have an output window. They're 2 different windows. If I save my data window, save as, if I save my data window, it saves as a .sav file. It doesn't save my output window. It's a separate window, right? Okay, so I need to save that window separately if I want to save it. Now, the problem here is that when I save this output window, I say save as, I save it as something called a .spv file. An SPSS output file. Okay, so we need to save both of them if we want to preserve them. Problem is that these output files in SPSS, if you don't have SPSS, you can't open them, can't access them. And in fact, if you don't have the same version as the other guy you're sending them to in SPSS, sometimes they don't open, right? So, that's not very convenient. But we got all this wonderful information that, I want to put this bar chart, this special bar chart, I want to put it into a report that I'm making in another class. What do I call this instead of a bar chart now? This special form of bar chart where the data, numerical data, is organized into groups. Anybody want to take a wild guess at this? It's called a histogram, right? And what's the difference between a bar chart and a histogram? Well, in a bar chart, it's individual groups that really aren't related to each other. For instance, the number of, if we're looking at hair color, the number of blondes, the number of brunettes, the number, and so on and so forth. 10 brunettes, 10 blondes, and so on and so forth. With these numbers, we're taking numbers that are on a continuous scale so that everybody that has anything between, say, 65 and 70 is in this box here. But the minute they get over 75, they go into this box. And the minute they get over 80, they go into this box. So there's no gap between them. Most of the time with a bar chart, you see a little bit of a gap. Remember I had that bar chart for the multiple counts? There were gaps between them, right? Because this is room 1, room 2, room 3. They're really not on the same number scale. This is actually values of blood pressure. So it has to go, if you get a new person and their blood pressure is 82.3, it has to go into one of these groups, right? So it would probably go into this group. Right? So it's a continuous number scale on the bottom, and these are groupings. Yes?
I don't know if I'm alone with this, but could you back up how to export from Excel to this, like how you got?
Sure. Most of the time in the beginning, I will give you both files, SPSS file and an Excel file, so you don't have to worry about that. But I'm gonna do that again so you can see it. And I also want to show you something else interesting about SPSS. The other thing that's interesting about SPSS is that at the bottom here, you may notice that there is a little tab down here, data view and variable view. See how that changed when I clicked on one and the other? Right? Bing, bing, bing. Right? What's happening there is there's really now 3 windows that we're working with. We're working with a data view, we're working with a variable view, and we're working with an output window. Okay? The variable view is one line. For every column that you have in the data view, each column is a variable. Blood pressure, weight, BMI, whatever they might be. Each column is a variable. Okay? In the variable view, you see one row that represents that variable. So for instance, right here, you see that column 1 is BP. It's a numeric variable. You can have up to 11 numbers going across the way it's displayed, 0 decimal places. You can give it a label, like instead of BP, you can say, oh, let's call that systolic. It isn't, it's the other, it's diastolic, but let's call it systolic blood pressure. Right? So that when it creates graphs or tables, it actually uses that whole word instead of just that little abbreviated variable name. Okay, SPSS is picky about variable names. They got to start with a letter. They can't have any spaces or special characters in them. And they can have letters and numbers, but it's got to start with a letter. Okay, and we can tell it what to do with missing values. What should I do if like, this person doesn't give us their weight, or their age or something like that? What should I do in that case? So you can tell it what to do with that. You can tell it how to align it, center it, so for view and so on and so forth. But most importantly, you can tell it what kind of variable it is. Remember when we were talking in lecture, there were several different kinds of variables. SPSS is most concerned about grouping them into 3 types of variables. One of them is nominal. Nominal is something that's a category or a name, like hair color, red, blue, green, yellow, whatever hair color is, right? And or gender, male or female, and so on and so forth. Scalar is anything that's a number, whether it's a whole number, whether it's an integer or a decimal number. It's anything that's a number. Blood pressure, age, number of cups of coffee you drink in a week, so on and so forth. Those are scalar or numerical. They call it scalar, but you could call it numerical. Nominal, scalar or numerical. What's ordinal? What's an ordinal variable? Did we just talk about that?
The order of something?
An ordinal variable is a variable that has order, right? But the order may not translate into an exact numerical value. For instance, if I told you to rate the first session on the level of technology that we've used here tonight and how successful we were, you might rate it either incredibly poor, just poor, horrible, so you might rate it on a scale, right? So that scale, the difference between really horrible and just plain poor may be different between poor and just kind of bad, right? The difference between those two may not be equal. So, for instance, the pain scale. Everybody's, if you ask me, give me how much pain are you in on a scale of 0 to 10, right? One person's 7 might be different than another person's 7. It's not like measuring blood pressure where you're using a sleeve and you're measuring millimeters of mercury, okay? And in fact, for a person, the difference between 6 and 7 for a person might be different between the difference between 2 and 3, right? But there is an order to it. So we call it order, since there is an order, but that order doesn't have the specificity that a numerical variable has, we call it ordinal instead. So we can have ordinal variables, nominal variables, or scalar numerical variables in SPSS. Okay, and we tell SPSS what kind of variable it is here. And if you get it wrong, and I call this a nominal variable, we got a problem later on when we do some calculations with it. It'll keep me from making certain kinds of mistake where I can't do that with a nominal variable, like find a mean or something like that. Okay, so I'm going to go back to the data view. Data view hasn't changed at all. So now I can also, so we have our output. I'm going to go back and show you how I did these calculations. Okay, here's our data. I'm going to import it again. Open, data. Happens to be in the file I want to go to because I don't have to navigate back to the folder I was in because it went right back to the place where I was in, desktop, PH750, session 1 files. But I don't see the file I want. I don't see the Excel file I want to import here. Oh, let me show you what that Excel file looks like while I'm at it, just so you know what it looks like before we import it. Open. Where is it? Session 1 files, SPSS. Okay, this is what the file looks like in Excel. Okay. You guys see it there? Okay, this is what the file looks like in Excel. It's got the first cell is the variable name, blood pressure. See, if we had BMI, for instance, it would be in here. And the person's BMI, I'm going to put a few numbers in here, 24, 34, 21, 34, 32, 28, 26, 25. Okay, so BMI, so this is person, this is subject number 2, his blood pressure is 85, his BMI is 24. The next person's blood pressure is 80, and his BMI is 34, and so on and so forth. So I'm going to save this file. Okay, and I'm going to reopen it this time. When I reopen it this time, I'm going to get a different file, aren't I? I don't see it because it's only looking for SPSS files. So I'm going to click down here and tell it, look in that folder for Excel files also. And sure enough, there's the Excel file we want to work with right there. 7 SPSS intro 2. I'm going to click open. And when it opens it, remember what it said before? It says, I see data between A1 and A11. Now it says I see data between A1 and B11. It sees 2 columns of data instead. Okay, and I'm going to leave, should I leave this checked off or not?
No.
Yes, right? Because the first row has the variable name, BP and BMI are in the first row. We don't want that imported as data. We want to use that as a variable name. I'm going to click OK. And bingo, there it is. Okay, if I go into variable 2, how many rows am I going to see now? 2, because each one of them represents. And it took a guess at it and said, oh, that looks scalar to me. BMI looks scalar to me, and it got it right. It'll take a guess at it. Okay, so remember, sometimes we represent even nominal data as a number. For instance, we might call in gender, we might call 0 female, 1 male. But we might call ethnic groups. One ethnic group might be 1, 2, 3, 4, and so on and so forth. We might use numbers so we avoid having to type in the names over and over again. And eliminate that kind of error in transcribing data and stuff like that. We might have upper and lower case and so on and so forth. Okay, so I got data view now. So now in order to analyze this data, to get the descriptive statistics, I'm going to go to Analyze, Descriptive Statistics. Frequencies is just going to give me the number of people in each group. I'm going to click on that just so you can see it. I'm going to move BP, and I'm just going to move BP in there for argument's sake. And click OK. And it gives me the frequencies. There's 8 people that are blood pressure 80 and so on. You see it there? This gives me the number of people in each group. Okay, I'm going to go back in there. Notice all of this, everything I've done since I started this session is in this output window. And if you're really sitting here doing a lot of stuff, it's also putting a little kind of outline on the left-hand side, so you can jump around between the different calculations that you've done, right? So I'm going to go down to the bottom here. That's the most recent one we've done. I'm going to go click Analyze, Descriptive Statistics. I'll go into Descriptives, and I'm going to put both of them in here now. I'm going to say, let's do the same calculations on both. Let's calculate descriptive statistics for both. I'll click OK, and there it does. It calculated descriptive statistics for BP and for BMI, blood pressure and BMI. 70, 21, so on and so forth, so on and so forth, and so on. I want to do that one more. I'm going to go back to variable name. I'm going to type into the label here. I'm going to type in diastolic. My spelling. Forgive my spelling and my typing. Right, I'm going to change that label. I don't need to change the value. Okay, I'm going to change that label. Okay, and now I'm going to go back to my data view, and I'm going to analyze this. I'm going to do the same thing again. Descriptive statistics. I'm going to say OK. Right. Notice when it makes the chart now, even though the variable name is still BP, it actually fills in the more extensive, more descriptive name for the chart, which is what you want, because if you have like a code name for a variable that doesn't make sense to people that are not reading, that are going to read your charts, you want to have a more descriptive label for your charts. So now I'm going to go back to Analyze, Descriptive Statistics. I'm going to go into Explore. Okay, and I'm going to do it for both of them. I'm going to move BMI and blood pressure both into this box, the dependence list, which is really just a list of things I want to do these calculations for. I'm going to click in plots, and I'm going to tell it, I want you to do a histogram for me also. And let's see, I'm going to say OK. Down here, I'm going to tell it, display both the statistics. I could say just statistics, just plots. I'm going to tell it display both. I'm going to click OK. And it's going to do those calculations for me. There you go. Did the calculations for blood pressure. See all these different statistics that it did. And for BMI. And it did histograms for blood pressure. We've seen this one before. And it did histograms for BMI. I wasn't very careful about the way I distributed this stuff. And a box plot for both of them as well. Okay, so it did all of these graphics and statistics for us. Okay, and the statistics and both of those give us an insight into how this data is distributed. Now, we call these 10 people what? What do we call this group of 10 people? That's a sample, right? Okay, are we really interested in what the blood pressure and BMI for these 10 people? Not really, right? What are we really interested in here? We want to know the blood pressure and the BMI for the population they came from. But, of course, that population might be everybody in New York State. Are we going to go around and measure blood pressure and BMI of everybody in New York State? It's not going to be very practical or economical to do that, is it? In fact, we very rarely ever get to see descriptive statistics for an entire population. What's the one place where we see descriptive statistics for an entire population?
Census.
Bingo, the census. Every 10 years they do a census, right? And in the Constitution, the census says you can't do statistics. You can't do a sample. you got to actually count every person. Right? It's actually in the Constitution. Right? That's why, even though we know that Hispanics in New York may be undercounted because some of them may be illegal and they may avoid the census taker and so on and so forth. And we know that to be the case, and we know what we might do to correct that so they're counted correctly statistically. We can't do that without a constitutional amendment. We can't correct for those errors that we know that are there statistically. Okay, that's the only place we really see a real population. We use samples to predict what the population or understand what the population is like. That's what these descriptive statistics of these samples do for us. And we're going to really learn about, when they're lying to us, when they're telling us the truth, and how well we can rely on them. That's one of the big things that we're going to do in statistics. Okay, so I want to show you one more video.